onto them. And you can get prizes for asking questions. Excuse me? I forgot. And with that, are you ready? Oh, sorry.
I can use this one.
If you want this one, I can use this one.
Hello? Does it work?
Right? And unmute like this.
Okay.
And with that, I would like to welcome Olga Maciaszek-Sharma from Codarte, talking about Accurest. Welcome.
Hello. I will be talking today about a tool for defining and testing REST contracts called Accurest. So first I will make a short introduction about the tool. Then I will talk a bit about the background, why we made it, what was the situation, what made us think of such tool. And then I will talk about the solution. Okay, so Accurest is a consumer-driven contract verifier. It will take as an input very easy to write groovy DSL scripts, and it will work automatically in Gradle to produce both YAML stubs and to produce tests. For now, we have Spock tests, and very shortly we'll also have JUnit tests. So who could benefit from this talk? Definitely any developers working with REST, QA engineers working with REST, people interested in the microservice infrastructure and the challenges it can cause. When it comes to the tech stack, it's a Gradle plugin, but some of our contributors would like to make it available for Maven, so we hope to have it available for Maven as well. Then it's written in Groovy, and it supports Groovy fully. It definitely supports Java. We have never tried using it with C, C++, or Objective-C, but as Gradle supports them, it may be possible for you to tweak it a bit and make it work for you. And of course, it's open source, so you can just fork it, you can tweak it, or you can just get inspired and make a similar solution for your own tech stack. So what happened was that the company that we've been making a project in was having a monolith system. It was a legacy system. It had considerable technical depth. And as any monolith, everything was contained in a single big application, a single logical executable. And what happened in that particular system, as it was quite old, the business process code in that system was already very entangled, and also the modules in that code were very entangled. And when you were fixing something, you wanted to work in one module, you could easily introduce a bug in any other module. So the development was resource-consuming, time-consuming. Then the testing of this system was also very long, and deployment process took a long time. It was not that bad, really, because it had a lot of tests, so it felt quite secure. But we thought, the architects thought, and they communicated to us that there would be a better solution to split it up so we could work in a more agile way. So we switched to microservices. So before, maybe we had client identification, client registration, different financial operations in the same one big app. Now we would have a different app for client identification, different one for client registration. We would have them all set up together and communicating with each other using REST. It would also influence the structure, the way we worked, because before any team would work on that big monolith system, and then after the change, what would happen is that any team would just work on one or more microservices. So they would be fully responsible for this application to work. And they would probably not communicate that much and not know that much about the exact inside ways of working of other microservices. So the new issues and challenges that appeared there were many of them, and people working there developed many tools to make it work smoothly. But now I would like to only talk about those related to creating and modifying REST contracts and also testing services that communicated using REST, because those issues caused the creation of Accurest. So when it comes to creating and modifying REST contracts, before there was one server, it had limited clients, and this approach was going to change. Now we would have many small applications, and any given application could be a server for other applications while being a client of any other service. So we would have much more REST interactions. And we would have to define and modify the REST contracts much more often. Also, we would like all the different teams working on the services to know that anything has been modified in a contract that we're using. So probably Service A was using a REST API of Service B, but Service C, D, and E were using that as well. So Service E requested a change. Now Service A has to know that this change has taken place as soon as possible. So these changes could also be simultaneous and maybe sometimes clash. We would like to work with this efficiently as well. And this has brought us to consumer-driven contracts, because if the client is the part that defines how the REST API should look, it is generally more efficient, it is better designed. Because with the big server approach, usually it is the server team that is taking decisions when it comes to the API, because this is the core component, so they are behind the main logic and everything. But with this approach, we want our clients to define what the contract should look like, because they know what will be the best approach for them to use this data. And then the second thing, we wanted all the consumers to be notified as quickly as possible about any change that has taken place. And when it comes to testing this service, before with the monolith end-to-end tests, what happened was that there were many of them. They were quite comprehensive. People, especially QA team, felt that the borders were well verified because there was a one big test environment and stage environment, and on that environment, the main server deployed, and any limited number of collaborators, and the end-to-end tests would fully use the communication between those applications. And they felt that it considerably improved safety. Probably there were too many of them. Probably the execution was too slow. Some code would get called again and again during those tests, but altogether it felt quite safe. So what could we do now as we were transferring to microservices? First idea was just to maintain it. Let's have it. Let's just deploy all the services at the same time. You could do that. Well, in theory, you could do that, but that would really go against the whole idea, because you want the services to be independent. So the development is quick, the deployment is quick, the testing is efficient, and if you had them all deployed together, only the development would improve. This wouldn't really make sense. So then we could make many such pipelines with all the collaborators there. One pipeline only used to deploy one service, but we would test them as we used to with all the communications. But we wanted to have many microservices, like 50, 20, later, who knows how many. So it would be extremely resource-consuming, time-consuming, and not worth it. So the idea that the architects came with was to stub collaborators. This is a known approach, used very often. However, what happened is that stubs do get corroded. So you might have written a stub one day, and it worked same as your server worked, but then somebody has updated the API on the server, deployed the new version, you have tested your own service against your stub, you don't even know that the server has changed. Maybe they've told you forgot to change this stub, and then what can happen is that your production, when you deploy to production, the communication can fail, even though the test passed. So there was too much human element here, and the better approach seemed to automate this. So the requirements when it comes to testing were that we would use stubs, but the stubs should be validated against the real responses of the server. So while showing you Accurest, I will talk a lot about client and server. And of course, as I've told you, we can have many clients and servers in this infrastructure. But now at any given time, I will just refer to a client as the part that is using the REST API and server as the part that has the REST API. So how do we work with Accurest? First, the consumer team, the team working on the client service, submits groovy DSL scripts that we'll shortly see as a pull request to the team that is working on the server. So scripts are used to automatically generate YAML stubs, but they also generate server tests. And these tests fail if they do not have the same implementation. So new server version cannot be deployed until the stubs and the implementation of the REST API are same. So they cannot merge this code and they cannot deploy until they have implemented the change, or they can just reject the pull request if they do not agree with this change, or if another team has made a similar pull request on the same endpoint, they want to introduce another field in the body, they can merge it, but they have to make it consistent. And now we'll go through this process. So first the client submits the script, and this is what an Accurest script looks like. As you can see, it's quite similar to YAML script or any JSON, but it's simpler in the syntax. At least it seems so to us. And it's written in Groovy, but as you see, you don't need to know any Groovy to be able to work comfortably with those scripts. So you have the request part and the response part. And the request part, you have, of course, the method, the URL, the body. Of course, you do not need to have a body in the request. It's optional. You can put as many headers as you need. And then in the response part, you have status and also body and headers. Now, what happens? The server team has this pull request. So they can run clean build with Gradle, and these stubs will be generated from those scripts. So this is a simple YAML stub, and it exactly matches the structure of our script. So we have the request, and in the request, of course, we have URL, method, and then the body part is changed to body patterns, and we are using JSON paths to check if it's the request that we want to send the response for. And of course, we check all of the headers, and then we just passed the response. I don't know how many of you have ever worked with YAML. Okay, so YAML allows you to run stubs during your test, and you just give JSONs, and it will set up a kind of test server where it will put these stubs, and if you send the request that will match the request in this pattern here, the response will be submitted. So just you don't have to have set up two talking artifacts, and you substitute the REST API of one of them with this. And I also recommend using YAML for any different purpose as well, not necessarily with Accurest. It's a very useful tool. Okay, so then you have the body. And the headers. Okay, so the server team has this, but as I've told, they can't do anything really. They can't deploy this thing. They can't merge the branch because they also have the tests, and the test shall fail. So this is what the test looks like. The nice thing is that it is automatically generated, and it will be always in keeping with the script. So you have one input and two outputs that have to be in keeping. In this test, we use REST Assured library. It is a nice library for testing any REST interactions. And all these methods like call or creating the request will be done using a REST Assured. So it's from a different library. So we have the script, and we use the body and the header parts of the script to create the request. And then we use the information in method and URL to really make the call. And then what we have to do, we have to verify if the server is giving us the same response that we have put in our stub. So we verify all the parts. We verify the status code, all of the headers. Then Accurest uses JSON path to verify if all the body parts that were specified are available there. So the only thing that you really have to do is set up a base test class and tell Accurest, this is my base test class, and all the Accurest-generated tests will extend this base test class. And to set it up, we work out with Spring, so it supports rest assured mock MVC. If you're using Spring, you can just do something like this. So you put standalone setup, and you give any amount of controllers that you need to launch. You launch them there, or you can just have a fully running application. You need to run it here. We're running it using web integration test annotation from Spring. We also support JAX-RS. So that's what you have to do. You have to set it up. Sometimes you have to add some mocks if you want to mock up the behavior, if you don't want to launch the entire application, or just use rest assured. So now now the server team has those tests. They're not passing, so they will implement the change in their REST API and in their functions to make them pass. Once that's done, the clean build will end up in success, and they can deploy. And it's very important while using Accurest to connect the deployment of the new version of the server with the deployment of the stubs. You can deploy the stubs to any artifact repository. It's up to you where. And you can use any tool that you would use for deploying things. So in Gradle, you have, for example, Maven Publish plugin. And it's very important to do this together. So now any client, any other microservice, can use those stubs, and they can be reasonably sure that if they are testing against those stubs, the deployed version of the other service, of the server, will behave in the same way as those stubs. So I would also like to talk to you about regular expression support. We have more features, but this is the feature that I find extremely important. When Accurest was created, I was one of the first users, and the first request we had, okay, you need to implement regular expression support. Without this, we cannot use it. Because when you are making a stub, a wiremock stub, what you expect to have, or you are just working with stubs, what you want to have is that, for example, you will send in your request a client ID and some other value, like here, loan amount that you want to take. And you expect a certain response. But it does not really matter if your ID is 1, 2, 3, 4, or 5, 6, 7, 8, or whatever other ID. It just has to match a certain pattern. Same if you're registering a client. You give request with client data, and you expect a response from the server. And maybe in your response, you expect a client ID, a UID, whatever. And it's not really important that it should always be the same. It will never be the same normally. But it's very important that if it's supposed to be UID, it should match the UID pattern. So then you want to check either verify or send request using a pattern and not a value. But as you know, Accurest also uses this data to create tests. So in a test, you cannot have a pattern. If you say, create a body with this field, or check that the body has this field, and then you want to make a call to the server and passing, or let's say my client is, and you cannot just say, I'm passing to you a client, and you know this client matches this regular expression. Now you have to say, in the request, I'm making a call, and in the body, the client has a real ID. So that's why it was very important to introduce different handling for the stubs and the tests. So the stub will just know that you can be sending anything which matches a pattern, but in the test, you will submit a value. So this is how we do this with Accurest. We use a value method, and we can give a different definition on the stub part and on the test part. And then you will usually put a regex in the stub part, and in the test part, just a value. And when we're talking about response, it's generally opposite. So you are expecting a response with a field of a certain type, of a certain pattern, not necessarily some defined value. Sometimes yes, most of the time no. So this script that I've shown you will translate to this stub, where if you see, instead of the 2 equal signs that we're checking for equal, we have now a different sign that is checking for matching pattern. And in the test, we'll just have the value that we specified. So we can make a call using that value. There are some other interesting functionalities that are supported. So we do have query parameters that can be useful for some of you. Optional fields are supported. That's maybe not that often used, but some people wanted to have fields that they may or may not have in the body, in the response. Then you can execute custom methods on the server. So say in the previous example, instead of just giving the value 1, 2, 3, 4 for the test, for your client ID, you could just write execute, generate client ID. And in your base test class, you implemented method execute or generate client ID. And also Accurest deals particularly well with nested structures. So when you know that you will have bodies that have many nested elements, which is very often true, Accurest will work out of the box with that. You don't need to worry. It will just resolve its maps, and it will make it work. So this is very useful. Now, I would like to tell you something about the possible issues. So we have found it to work very easily and out of the box and with minimal setup in the real microservices that were very small applications. But we were then quite enthusiastic, and we tried using it in this complex legacy system as well until it has been decoupled into microservices. And this has proved to be complex because there was a lot of things. We didn't want to launch this application each time because it was too heavy. So we had to mock it. There were many mocks, and the problem was that currently Accurest only supports one base test class. So you had to have all those mocks in one class or in some class that the other class was extending. It had to be in the same hierarchy, and we had many modules. That was quite problematic. This is probably a room for improvement for changing it. Yeah. And then the Gradle setup, if you had multi-module Gradle project, the setup can sometimes get very complex, especially if you have a lot of things happening in the Gradle itself. As Gradle allows big liberty in writing it and changing the ways that the builds are done and using dynamic functions. So in that project that was already so complex that setting it up with Accurest was a hassle. And some other possible issues. It's a young solution. I think it has been there for a year or so. So there can still be bugs. The good thing is that the Accurest team is working very much on the bugs. So the support is constant, and we try to fix any bugs that there may be, and we try to introduce new functionalities that people need. So that's a part, bad thing, part, good thing. Yeah, and now I'd like to show you a demo. Okay, so here we have a very simple demo project. It has only been written for the demo, so please don't put that much attention to the functionality itself. And it has two smaller Gradle projects. So these two smaller Gradle projects, we can imagine they are just two different jars deployed somewhere in the network infrastructure. So the first project is a loan application service. It's very simple, and it will just make a request to a fraud detection service that we will see shortly, and interpret the answer. And it's very simple. Either the answer can be OK, or the answer can be fraud. So if it's OK, the loan is processed, and if it's fraud, the loan is rejected. And then you have another service called fraud detection service. This is where we are making the calls. It has extremely small API, has one controller, and currently it only returns OK. And the functionality that the client is expecting is the commented out, that it should also reply that the amount is too high if it's higher than 5,000. And then it should reply that this client is a fraud. So this is not implemented. So what happens now? And also, there are no scripts yet, and no stubs, and basically nothing. And the loan application service has a test. These are some Spock tests. So basically, it expects either a server to be running the fraud detection service, or using the wiremock rule, having stubs loaded to the wiremock rule, to the wiremock, and also replying same as the server would reply. So now, what will happen if we just run clean build? Our loan application service test should fail, because they are trying to communicate with the other service, which is not there. OK, it failed. Loan application service tests have failed. And if we see why they fail, it is because, 1 second. Because as we expected, there was no response from the server. So what we will do, we will now add some scripts. And the scripts have been already previously added. So we just need to reset gate. And we can see the script here. So if we go to mappings, we have nearly the same scripts that I've been showing. So we have the scripts, the stubs will get generated, the test should get generated, and one of those tests should fail because the implementation is commented out. So if we do run it now, effectively one of the tests has failed. And we can see the report here. Yeah, so it's expecting to get fraud. It's getting OK. And let me show you what really was generated. So in the build, if we see generated sources, here are the tests. And the first one is obviously the one that fails. It expects fraud in the body. There's no fraud. And then here, we will have the script. So this is the way that this solution works. And I would also like to suggest you to, if you got interested, if you think you may use it in your project, to check out, first of all, Accurest code. and see if it's useful for you. If you need it for some different tech stack, maybe check if you can do something similar. If you want to use it but you see some problems or there's something lacking, make a pull request or just make a bug or new issue. And then you can check out the project with the examples that I've been showing. It has many branches with different stages of the setup in every branch. So if you like to check it out, you can play with it, and if you have any issues, you can approach me. I will be in the conference, and I will be ready to help you with that. And yeah, you can contact me about this, and now if you have any questions, that's the good time to ask them.
I have a question about who use that software, like Accurest.
I couldn't hear you.
Do you have use Accurest?
Yes, we have definitely, especially we have one big users from the financial sector, and they use Accurest a lot, and mainly to their requests and their bugs that they made, we have improved it, but now we are also getting more and more users from different companies because there's a whole movement of switching from monolith to microservices. Many companies are going to that approach, and Accurest really has little alternatives. There are some alternative frameworks, but they're more difficult to use normally. They're more complicated. So we are getting more enterprise users now.
Okay, one question. REST is not only about HTTP protocol. Do you plan to support also different transport protocols other than HTTP for this?
For now, we have been concentrating on HTTP. But as I've told, this is being developed very intensely, and we are happy to make things that will users make more comfortable. So if anybody needs something, you can just make an issue and will be definitely considered. And if there are no major reasons not to do that, that will probably be implemented. Also, if you want to implement it, everybody is invited to participate. It's open source.
Okay, and do you have any roadmap for the project? What do you plan to implement in future? Do you have any roadmap for the project? Any plan what will be implemented in near and far future?
Yeah, for now, the main functionalities that we needed and we are using in our work were implemented. But so for now, what we want to do is JUnit. We very much want to support JUnit, and it's in a branch, it should be supported soon. What also we have done was switching to JSON paths, because some time ago we had our own written validation of the JSONs, and then we realized that maybe it didn't make that much sense if there was something very good in already there, so we switched to that. And we are also getting many issues from users, so we are just fixing it. So I think for now it's JUnit when it comes to things that we want to add. And also there are, as I've said, some contributors that would like to make it available for Maven. So we very much hope for it to also come to Maven.
Thanks.
Okay, so if there are no more questions, you can always come and ask me if you have later on questions or you just don't want to ask them now. I will be here today and tomorrow all day long, and feel free to come, feel free to check out our code and comment about this. Thanks.
Thank you. Thank you, Olga. I would like to remind all of you to go sign up or at least vote for lightning talks. There's a board in the main hall.
Yeah. right, thank you. Yeah. Yeah.
And what about this?
Oh, I'm sorry. I
remember
forgot. Yay.
The big Okay, I remember one of them.
Yeah, this one, but the other one I do not remember. I'm sorry. I just forgot about them. Yeah, I think that, do I have wrong watch? Because I got 5 minutes before, and I thought we started at 9:50, and we were.
During miscommunication, they told me that you reserved like 5 minutes for questions.
Okay, no problem. Yeah, sure.
I didn't catch it, but is it possible to validate also the request part?
Yeah.
As a unit test to try it?
No. For now, no. Do you think it would be valid?
Maybe you want to put off your microphone.
Oh, sure, sure.
něco říct?
Raz, dva, tři, raz, dva, tři. Počuješ mě? Raz, dva, tři, raz.
So, hello everybody. There was change in schedule. Next presentation, it's going to be about network manager. And